Have you ever heard someone say, "It's just a snapshot, we'll delete it later"? That one sentence has caused countless production issues in enterprise environments. VMware Snapshots are incredibly useful, but they're also one of the most misunderstood features in vSphere. A snapshot might look tiny today, yet weeks later, it can become the hidden reason behind slow databases, storage latency, failed backups, and even virtual machine outages. In this video, we'll uncover what really happens inside ESXi when you create a snapshot, why performance slowly degrades over time, and how enterprise teams avoid these costly mistakes. Let's begin with a real production story that many VMware administrators have experienced. Imagine a production SQL server protected by backup software. Before the backup starts, the software creates a VMware snapshot. This allows the backup to capture a consistent state of the virtual machine while users continue working. Now imagine the backup job fails halfway through. The backup stops, but the snapshot remains. Nobody notices because the application continues running normally. Over the next few weeks, thousands or even millions of disk writes are redirected into the snapshot's Delta disk. Users eventually report slow applications, database queries take longer, storage latency increases, and administrators begin troubleshooting CPU, memory, and networking. Only later do they discover a massive forgotten snapshot. This isn't unusual. It's one of the most common enterprise causes of VMware storage performance issues. So why does this happen without anyone noticing? Here's what makes snapshots so deceptive. Immediately after creating one, its size is almost zero because VMware doesn't copy the entire virtual disk. At that moment, performance usually looks normal. Applications continue running, and monitoring dashboards rarely show any warning signs. This creates a false sense of security. Administrators assume the snapshot isn't affecting anything because everything still works. But snapshots don't become dangerous when they're created. They become dangerous when they're forgotten. Every new write slowly increases the amount of work ESXi must perform behind the scenes. To understand why, we first need to see how snapshots actually work internally. One of the biggest misconceptions is that VMware creates another complete copy of your virtual disk. It doesn't. When you create a snapshot, the original VMDK becomes read-only. ESXi then creates a new Delta VMDK, sometimes called a redo log. From this point onward, every new block written by the guest operating system goes into that Delta disk instead of the original VMDK. The base disk remains unchanged until the snapshot is deleted and consolidated. In other words, snapshots don't duplicate the disk. They simply record every change made after the snapshot was taken. That's why they start small, but continue growing as your workload changes. Now let's see what happens every single time your virtual machine performs a disk write. Without a snapshot, the process is straightforward. The application writes data through the guest operating system directly to the VMDK. Simple and efficient. With a snapshot in place, the path changes. Instead of writing directly to the base disk, ESXi redirects every write into the Delta VMDK while maintaining metadata that maps changed blocks. This extra layer introduces additional processing and lookup operations. For a lightly used virtual machine, the impact may be minimal, but for write-intensive workloads, those extra operations happen thousands of times every second. Over time, that additional overhead becomes noticeable, and the situation becomes even worse when multiple snapshots exist. Many administrators assume having 3 or 4 snapshots isn't much different from having one. In reality, every snapshot adds another Delta disk. Instead of managing one set of changes, ESXi now maintains a chain of Delta files. For many read operations, ESXi may need to determine which Delta file contains the most recent version of a block. As the chain grows longer, metadata lookups increase, storage operations become more complex, and latency rises. This is why VMware recommends keeping snapshot chains short and removing snapshots as soon as they're no longer needed. Some workloads are affected far more than others. Database servers are usually the first systems to show performance degradation. Applications like Microsoft SQL Server, Oracle Database, SAP HANA, PostgreSQL, and Exchange generate continuous write activity. Every transaction updates logs, indexes, and database pages. With an active snapshot, every one of those writes is redirected to the delta disk. As write rates increase, storage latency grows, transaction response times slow down, and users begin experiencing delays. That's why a forgotten snapshot often appears as a database performance issue, even though the database itself isn't actually the problem. So, what symptoms do administrators usually see? The first complaints rarely mention snapshots. Instead, users report that applications feel slow. Database queries begin taking longer. Backup jobs run past their normal maintenance windows. Storage latency gradually increases. Datastore usage starts climbing. Interestingly, CPU and memory utilization often remain completely normal. That's what makes snapshot-related issues difficult to identify. The bottleneck is usually storage, not compute resources. Now, let's clear up one of the biggest myths in VMware. This misconception still causes serious production incidents. A VMware snapshot is not a backup. A snapshot only stores changes made after the snapshot was created. It still depends entirely on the original VMDK. If the datastore fails, becomes corrupted, or is accidentally deleted, both the original disk and the snapshot are lost. A true backup is an independent copy stored separately from the production datastore. Snapshots provide temporary rollback capability, not long-term data protection. There's another misconception that's just as dangerous. Some administrators think if one snapshot works, several snapshots must be fine. Unfortunately, that's not how VMware snapshots behave. Each additional snapshot creates another delta layer. Metadata processing increases, disk operations become slower. Eventually, snapshot consolidation becomes more time-consuming and more likely to fail if storage is limited. Long snapshot chains increase operational complexity and raise the risk of production outages. The best practice is simple: fewer snapshots kept for shorter periods. So why does performance seem to get worse little by little instead of all at once? Snapshots rarely create immediate problems. Instead, the delta disk grows with every new write. As it grows larger, ESXi performs more metadata lookups, storage operations take longer, and latency gradually increases. This slow decline makes troubleshooting difficult because administrators often notice the symptoms weeks after the snapshot was created. By then, the snapshot may already be hundreds of gigabytes in size. The longer it remains, the greater the performance impact. Eventually, every snapshot has to be removed, and that's where another risk appears. Deleting a snapshot doesn't simply erase a file. Instead, ESXi performs a consolidation process. Every changed block stored inside the delta disk must be merged back into the original VMDK. For large snapshots, this process requires additional datastore space, sustained storage performance, and uninterrupted I/O. If the datastore becomes full during consolidation, the process can fail. Now the virtual machine remains in an inconsistent snapshot state, increasing operational risk and requiring immediate administrator attention. This is one reason VMware recommends maintaining sufficient free datastore capacity before removing large snapshots. Let's summarize the real business risks. Large snapshots don't just slow down a virtual machine, they can impact the entire business. Data stores can run out of free space. Snapshot consolidation may fail. Maintenance windows become longer. Backup operations may fail or take much longer to complete. Applications experience downtime. In extreme situations, storage problems during consolidation can increase the risk of virtual machine corruption or incomplete recovery. What started as a simple forgotten snapshot can eventually become a production incident. Fortunately, these problems are almost entirely preventable. Enterprise VMware teams follow a few simple rules. Keep snapshots temporary, remove them immediately after backups, upgrades, or testing are complete. Monitor snapshot age regularly and investigate any snapshot that remains longer than expected. Avoid maintaining long snapshot chains. Always ensure sufficient free data store capacity before consolidation. And never ignore snapshot consolidation warnings. They're early indicators that something needs attention. These small operational habits prevent some of the biggest storage issues in VMware environments. So what's the most important lesson from everything we've covered? Snapshots are incredibly valuable, but only when they're used for the purpose they were designed for. They're perfect before upgrades, patching, configuration changes, or short-term troubleshooting because they provide a quick rollback option if something goes wrong. But they were never designed to replace backups or provide long-term protection. Think of a snapshot like a temporary safety net. Use it briefly, complete your work, then remove it as soon as possible. That's exactly how VMware intended snapshots to be used. Before we wrap up, here's one final reminder. The next time someone says, "It's only one snapshot," you'll know what's really happening behind the scenes. Snapshots don't usually cause immediate failures. They quietly grow until storage performance, backup operations, and even production availability begin to suffer. If you found this deep dive helpful, please like the video and subscribe for more VMware architecture explanations based on real enterprise scenarios. And I'd love to hear from you in the comments. What's the largest VMware snapshot you've ever encountered in production? I'll see you in the next VMware Deep Dive.